Hello. So in this video, I'm going to address how do you know when you see a bunch of numbers in an algebraic function, how do you know which numbers cause horizontal effects and which ones cause vertical effects? Okay. All right. So first of all, what really is sort of the dividing line between the two is the actual process that gives rise to the shape of the function. So so when I say the function, and I'm putting that in air quotes, what I mean is the operation that gives the graph its distinguishing shape. So in this right here, for example 1, it's the cubing process. It's when you go and you actually take the cube, that is what gives the function its shape. So everything before that, any operations that occur before the cubing process cause horizontal effects because they're inside the function. And everything that comes after the cubing process is outside the function, and that causes vertical effects. So for example 2, what is the function? Well, the function is the square root. And the square root, what comes before it? The 4. What comes after it? The half. So the 4 causes a horizontal effect because it's inside the function or before the function. The half causes vertical effects because it's after the function or outside the function. In example 3, here you have a reciprocal function because the x is in the denominator. So the basic shape is 1 over x. And you could write, well anyway, I'll show this later where you could write the 9 outside. But anyway, anything before the reciprocal process is inside the function. That would cause a horizontal effect. Everything that's after the reciprocal process is outside the function and a vertical effect. And for number 4, example 4, the basic shape is absolute value of x. So everything inside, so basically the 1/5 and the -4, those are causing horizontal effects. They affect the x coordinate. Everything outside, so this would be like a -1, even though it isn't written there, -1 and a 2, are out after the absolute value, so they're outside the function, and they cause vertical effects. So coefficients that affect the input or the x coordinates, well, usually they're x coordinates, they don't have to be, but basically come before what I call before the function or before the operation that gives rise to the distinguishing shape of the function. Those cause horizontal effects, and then coefficients that come after the function cause vertical effects. Now, if you look just at a general y equals a, here's your function, like that could be the square root, or that could be the cube, or the absolute value. And then bx plus c that's what they call the argument or the input, plus d. So these cause horizontal effects, these cause the vertical effects. Okay. So now let's take a look. Oops. Sorry. Here, when you look at that cubing process here, the -1, you can look at it as a plus of -1. That causes a horizontal effect. Then comes the cube. Then you have the 2 and the -7. Those are vertical effects. Here, the square root, the 4 comes before the square root, so that's a horizontal effect. Then the half comes after it. So the half causes the vertical effect. The 4 causes the horizontal effect. Oops, sorry about that. My cats ran all over this and I had to rearrange this. Sorry, example 3, the reciprocal. Let me check that this is, yeah, the reciprocal. So I can write this 9 outside, and then you see the 1 over, and then you have your denominator. So you see that the 3 and the 4 here are horizontal, cause horizontal effects. The 9 and the 1 or the -1 cause the vertical effects. And then for the absolute value, the -1 and the 2 are outside the absolute value. The 1/5 and the -4 are inside the absolute value, so they cause the horizontal effects. And I might have a cat helping us here. So let's say we look at, for example, example 1, and let me make sure this, yeah. So if you're still unsure and you're like, I still can't really tell what's inside and what's outside the function, go ahead and put an input into the x or the input variable. So in this case, let's say I put 5 in for x, and then look at the operations that you're doing. Well, we know the cubing process, that's actually the function. So anything before the cubing process is a causes a horizontal effect, and everything after the cubing process causes a vertical effect. So when I put in 5, what's the first thing I do? I subtract 1. Well, I still haven't cubed, so that's the subtraction by 1 is a horizontal effect. Then I get 4 when I do 5 minus 1, so I get 4. That's when I cube. That's the function. That's like the barrier between before and after, all right? So that's just what's demarcating before and after. Now, once I get that 4 and I cube it, that's causing the shape of the graph. After that, you're multiplying by 2, right? You're multiplying by 2. That comes after the cubing process, so that's a vertical effect. And then you subtract 7, so that comes after the cubing process, so it's a vertical effect, all right? And then let's take a look at example 3, which was 9 over 3x minus 4 minus 1. That's the reciprocal function. Let's say I put in 2 as the input, so I put in 2 here for x. What's the first thing I do? Well, I multiply by 3, so I haven't taken a reciprocal, so that's a horizontal effect. Then I get that 6, and I subtract 4, still haven't taken a reciprocal, so that's that 4 there's a horizontal effect, right? Plus a negative 4. Finally, I go ahead and say, oh, 6 minus 4 is 2. Now I'm going to do 9. I'm basically saying 1/2, and then I'm going to multiply by 9. So the 1 divided by the 2, that's the 1 over x. So I probably should write it kind of like that. This is really 9 times 1 over x, which is the 2 in this case, because that's what I put in. There's your reciprocal. That causes the function, the shape of the function. Then, when you multiply by 9, that's now after you've already done the reciprocal. So that's a vertical effect. And then you subtract 1, and that's after you've already done the reciprocal operation, and therefore it's a vertical effect. So hopefully that can help you distinguish between how do you tell vertical and horizontal effects. And the basic recap is right here. Coefficients that affect the input before the function, right, before the operation that gives rise to the distinguishing shape of the graph, those cause horizontal effects, and coefficients that come after the function, they cause vertical effects. And in general, when you write a function or an algebraic function, this is how you write it. Sum a, coefficient a times the function, and then in the input to the function is a bx plus c, and then you have something like plus or minus d kind of thing. So B and C are going to be horizontal effects. A and D are going to cause vertical effects. Thanks so much for listening.